Okay, so 8:35 and welcome. I wonder, wonder how many people are going to show up on Thursday. We'll see. I guess 8:30 classes are tough, especially on a day like today. Um, Today is the 28th of January, so you should have submitted tutorial 3 and assignment 1 over the weekend. And then test 1 is coming out. Before I talk about that, let's talk about assignment 2. It's not out yet. I expect it to be out sometime this week. I am hopeful for maybe today, but probably more like tomorrow. Um, the prototype is done. I just have to write up the specification and make sure that I don't know, make sure it makes sense. So yeah, that should be out this week. Very similar to assignment 1, except we will talk more about things like encapsulation and memory management and memory leaks stuff like that. So today I'm going to finish up talking about memory management, dynamic memory, and then we're going to take up the practice test. Um, and then after that, we will probably talk about software engineering in general. But yeah, any questions on the schedule? Okay. Where we left off last class was dynamic memory, and we had been talking about, well, we had made this little application of a calendar, right? So we had a calendar class, and it contained an array of date pointers, and then we dynamically allocated those dates inside the calendar class. And then we had, we took responsibility for deleting that memory after, right? Either in the remove function for the calendar class. So remove event, if we remove an event, we delete it, or in the destructor, right? So that way, no memory leaks whatsoever, right? So for every corresponding new, we had a delete. And in some sense, it's not quite encapsulated. And by that, I mean like, well, if I take away this get event, then there is no indication that I'm actually using a date class behind the scenes, right? So my calendar class, the public-facing interface, does not give any indication of the implementation, right? So I hide all of that, and then I take full responsibility for allocating and deallocating. But let's say that I want to expose a little implementation detail, right? Like date is not a big deal, arguably. So maybe I want the user to be able to manipulate the dates directly, or at least to be able to read them and look at them and things like that. So I have this get event, and it returns a date pointer. All right, so that is, as far as I'm concerned, the very sensible way to get a piece of dynamic memory out of a class like the calendar class. So I give you this pointer, and then you can do whatever you want with it. If this is maybe a remove function, then maybe you're responsible now for deleting it. But if it's just a getter, probably I would make this const, right, which we'll talk about later, so that you cannot manipulate it, but you can read it and you can print it out and do whatever you like with it. So another way to do get event is, well, if you're working in C++, at some point you might see, that's not it, this one. At some point, instead of a simple getter that has a date pointer return value, you might see something like this, where I still want to return a date pointer, but I want to do it as an output parameter. Okay, so to do that, I have to pass in a date pointer by reference. In other words, I'm going to use a double pointer, so a pointer to a pointer. Again, this is like not really intuitive. Getters are like a return value so much easier, but if you're dealing with legacy systems, you might see something like this. So we're going to implement this in my this part. All right, so to start with, very simple. We're going to make a calendar. We're going to add some events. We're going to print them out, make sure everything's working correctly, and then we'll implement this get date function using a double pointer. And so lo and behold, these are, the formatting's not great, but these are my 3 events that I'm keeping track of. They're even in Are they in order? Yeah, they're even in order. Okay, so now I want to get a date from my calendar class so that I can, whatever, put it in a spreadsheet or something. So I'm going to declare a date pointer. That's going to hold the date that I'm returning. Now, if I look at the function prototype, it returns a Boolean, right? So this means that, well, if I can find a date that matches this event, then I did return you a pointer. And I return true here to indicate that this pointer is now valid. If I can't find that date, I'm going to return false. And that means you should not try to dereference this pointer because it has whatever garbage you sent in. So I'm going to say if, and then cal.getEvent, and then I want to pass in, let's say what, y2k is my event I'm looking for, and then I want to pass in this date pointer. I want this date pointer to point to whatever the date I'm returning is. But this getEvent method takes a double pointer, right? I'm passing it in by reference, so what I want to do is pass in the address of this date pointer. And then if I return true here, then presumably my date pointer now points to something, and I can say d pointer arrow operator print, right? So I can print out my date. Otherwise, I'll say event not found. Okay, I haven't implemented this get function yet, but this is how it should work. So if I look into my calendar class now, okay, so I passed in a date pointer by reference. Well, the first thing I'm going to have to do is look for this event. So I'm going to use a for loop. Some dates. And then, yeah, if, what do I call it, dates? Yes. I believe I have an equals function that takes a string. And so if that is true, then I found the date that I want, and now I want to return it. And how I want to return it is I want to assign it to the date pointer that they passed in. And how I get back that date pointer is I dereference the double pointer. If I dereference that double pointer, I get back a single pointer, and then I can say, well, copy in the address from this location in the dates array. At which point, now I have some valid data there, so I'm going to return true to indicate that the person who called the function can safely use this pointer. And then otherwise, I go through the entire list of dates or the array of dates. I do not find the event that I'm looking for, so I return false. All right, questions on that? Okay, you got to work with it a little bit before this becomes natural to you, right? So yeah, I guess I have my main. If I look at the code now, so I should be able to find y2k and then print it out. Let's add a little bit of formatting. Yeah, that should be fine. Okay, so my calendar, December, January, but I'm interested in this y2k thing. So when I try to get to that y2k date, it returns true, and I've assigned that, that date pointer to my output parameter. All right. Not very intuitive, kind of clumsy. This is more of a C thing, but of course, C, C++, there's a lot of mixing that happens, so it is good to know how to do this. Yeah, questions? All right, so some of the typical problems are, well, somebody takes a look at this and says, well, this takes a double pointer. So if I wanted to use it, I'm going to declare a double pointer and pass that in, right? Now I no longer take the address of, and then if I want to dereference it, or sorry, if I want to call the print function, well, I have to dereference it. I don't know why, you know, I'm just making the compiler happy in this case. Syntactically, this is going to work. But what's actually going to happen when I run it is I get a seg fault, right? Because, well, before my double pointer actually pointed to a pointer. I had a pointer and then I sent in the address of it. So my double pointer now, if I follow that address, I land on an actual pointer. But now when I just simply declare a double pointer, if I go into the implementation and I dereference this double pointer, I don't get back a pointer. I get back garbage, whatever garbage it was pointing to, right? So that is a common mistake because syntactically the compiler is happy, right? It wanted a double pointer, I gave it a double pointer. But that's not really what we want to have happen here. Yes. I mean, there's almost no way to do it except practice. Or think, or draw things out very carefully. You know, for myself at least, like being able to explicitly draw out where these memory models. And so like if I have a double pointer, like what does it point to? And then I can dereference it. So what is it returning if I dereference it? So these I find are useful diagrams. I don't know, maybe you guys find them useful as well, maybe not. But yeah, questions? Okay. So that was all the way down here. Double pointers. Okay, so I could, I don't know why I'm so blurry here. I guess it's loading up my thing. All right, whatever. So yeah, I skipped this stuff. We can go through this if anybody has any questions or concerns, but again, I usually don't put this double pointer. Well, occasionally there's an opportunity to put a double pointer in an assignment, but I'm not a huge fan. Why the compiler gives you a seg fault? Yeah, for sure. I wish this page would. Okay, well, I'll walk through this and then explain why we got the seg fault. So if I'm using a double pointer, so first, well, I'm going to declare an int and I'm going to give it the value 42. So the name is I, the type is int, the value is 42, the memory location is A8. Now I'm going to declare a single pointer, I pointer. What happened? This is really not working with me today. Let me see if I. Okay, let's do this one, which is basically the same thing. All right, so the name is I, the type is int, the value we'll put here is 42, the location is A8. Hopefully it doesn't erase automatically. It seems to be okay. Here my name is I pointer, the type is int pointer. My value is, well, let's take it and assign it the value of the I address. So the I is at location A8, so its value is A8. Its location is AC. And then I will take my double pointer. It's called a double pointer. It is of type int pointer pointer. Its value, well, here I'm going to assign it the address of I pointer. And so the address of I pointer is AC, and the address of this is B3. Right, so this is A8, and this is AC. So this points to here, and this points to here. So in this case, my double pointer is valid. So I can do something like, well, I can dereference my double pointer once, and I get back what? I get back this address, and at this address, I have a single pointer. Sorry, I get back this address. At this address, I have a single pointer, right? So then I can assign that single pointer a value if I want. So in the example we just did, I passed in this double pointer that was pointing to a valid pointer, and then I dereferenced it. I gave it the address of the pointer I wanted to return, and then I returned. what happened when I just declared the double pointer without declaring the single pointer first and then passing in the address? Well, this double pointer now points to nothing. So all I did was declare a double pointer. I didn't assign it a value. So it's not actually pointing to a single pointer. And then if I pass that into my function and I try to dereference it, I get a seg fault, right? Because this is not a valid memory location. It's just some piece of garbage. Again, you almost have to sit down and draw this out yourself in order to be comfortable with it. But yeah, that's what's happening. If I just declare a double pointer, it's not actually pointing to anything. In order to make it useful, I have to point it to a single pointer. In the example, well, I'm passing in, if I go to here, I'm passing in a double pointer. So it's going to, on my stack frame, I'm going to have this double pointer variable, and the value that I'm going to give it is the address of the single pointer. And so then when I dereference it, I get back a single pointer. If I just declare a double pointer and dereference it, I get back whatever garbage was there. Hopefully that makes sense. Questions? Okay. Let's look at, finally, we're going to look at arrays. So we're going to look at all the types of arrays. So we've primarily worked with statically allocated arrays of objects. So we're going to review all of that. And then, so there's basically 4 types of arrays. Well, let's say that there's 2 types of arrays and then 2 places in memory where I can store them, right? So the 2 types of arrays are arrays of objects and arrays of pointers. So in our assignment, our first assignment, we've been using arrays of objects. In our second assignment, you're going to be using arrays of pointers because they're slightly more efficient. I don't have to allocate all this memory up front. I can kind of allocate as I add things to my collection class. In addition to that, however, I can put the array on the stack or the heap, right? That's sort of a simplified model, but essentially that's what we're looking at. We're looking at arrays that are on the stack or the heap, and they contain either pointers or objects. Where I put the array does not affect the syntax I use. It's just a memory location at the end of the day. But it does affect how I make the call to allocate it and whether or not I have to delete it. Okay, so let's look at the first example. So I have a date class, no events, just the plain old date class. And then I have a bunch of, I don't need this. I have a bunch of functions I'm going to call. The first is static objects, so statically allocated arrays of date objects. Okay, so this is, this is the same syntax we used for assignment 1. This is the same syntax you're going to write on test 1, right? So the type is date. The variable name is array1 or ARR1. And then this indicates that it is an array and its size is max size, which in this case is 2. In our diagram, I'm going to do 3 just because, I don't know, it looks better. So what happens in terms of memory is that, well, I have my main function. I guess it's in static objects, but we'll pretend this is in main. I declare this array of date objects, and it's statically allocated. So on my stack frame, this array is allocated. Inside each of these locations is a date object. The default constructor gets called on each of those date objects. So now they're all reading like 1901, 01, 01. And then I can assign it values. So I can, that was stuff I think that just contributes to the general confusion about this. So some of the stuff I'm going to erase, but yeah, so I declared this array of dates and then I can just print out all of the dates. And to do that, of course, I use the normal array syntax with the subscript operator, the square brackets. The subscript operator returns a date object, so I use the dot operator to call print on it, right? So yeah, if I run this, I'll print them all out, and then I will set the dates to something sensible and then print them out again, right? So in the first case, they get the default values. Okay, so when I allocate the array, the default constructor is called on both of the dates. When I print them out, I print the dates out with their default values. I call set date on them, and I change the values, and then I print them out. And then they're destroyed for me automatically, right? I don't have to call delete. Statically allocated objects get destroyed automatically, and statically allocated arrays get recollected automatically. And this is, yeah. Questions on that? This is assignment 1 and test 1, basically. We're going to cover it again when we go over the assignment, but okay. So now we're going to do something a little bit different. We're going to do a statically allocated array of pointers. So what does that mean? Well, basically, I have the same model here. I have my main function. I have the stack frame, but instead of an array of dates, these are now an array of date pointers, which means that when I allocate this array, no date objects are made. So what I'm going to do is I'm going to make some date objects on the heap. So I'm going to say new date, and then I'm going to assign that date, or at least the pointer to that date, to that place in the array. Right? So I'm going to make a couple of new dates, and I'm going to have the pointers in this array point to those dates. And this is what our memory map is going to look like for this next example. So my next example, all right, so I'm going to statically allocate an array. So same before, the array name and the size, but here now the type is date pointer. Okay, so that's it. Now what can I do with this? Well, I try and print it out, right? Since this subscript operation now returns a pointer, I need to use the arrow operator instead of the date operator to print, right? This is, of course, I did not yet make any new dates, right? So I have an array of pointers that points to nothing. And when I try and dereference them and call print, I get a seg fault. So this, yes, it's pointing at garbage. I get a seg fault. So let's give it some values. Let's get rid of that. So I can make a new date. I can assign its address to this pointer, and then I can copy the address from this pointer into my array of date pointers. Or I can skip that intermediate step and just make a new date and assign the pointer that's returned directly to my array. At which point, then I can safely print out these two dates in 1955 and 1966. I'll come back to this in a second. Okay, so yes, I constructed two dates when I called new on each of them, 1955 and 1966. I printed them out using the arrow operator. And then, well, then you can see the destructors were not called. Because these are on the heap, I have to call the destructors, or I have to delete them explicitly. It does not get deleted for me. So at the end, I call delete on these two things, these two dates, and these two dates destructors are run, and I don't have memory leaks. The array, the statically allocated array, that gets deleted for me, right? Because it's statically allocated. All right, questions? Okay. The next example is, well, the same as the first one. I'm going to have an array of dates, date objects. But this time I'm going to say, well, it's too big to put on the stack. I'm going to put it on the heap. Yeah, actually, yes, that is exactly right. The pointer itself is on the stack. The new date creates a date object on the heap. That's exactly correct. So yeah, it would be something like this. I have a date pointer, and it points to a date. So what we're going to do this time is something similar. I'm going to make the same statically allocated array I did earlier, but I'm going to put it on the heap. I don't want it on the stack because maybe it's too big. So I'm going to dynamically allocate this array on the heap. I'm going to say make a new date array. It's going to have the date objects inside. The constructor is going to get called automatically on those. And then up here, I'm going to have, well, I'm actually going to have a date pointer. And yeah, so this date pointer is going to point to this array of date objects. Okay. So I go to a dynamically allocated array of objects is here. Again, some of this stuff I think just confused the issue in prior iterations. Okay, so to make an array of date objects on the heap, I use the new keyword along with the subscript operators. The type is date. So this makes a new array of max size of dates, and I assign it to a date pointer. Right, you can think of it as, well, it's a date pointer. Since it is an array of objects, I can as soon as I allocate it, I can print them out. Right? The default constructor is going to be called on them, and then I can, call set date on them. They're objects, so I need the dot operator, and then print them out again. Let's actually, before I do this, let's just look at what happens. Okay, so I make my two dates. When I call new date, that's when these are made. They have default values. I can assign them values, and then the end of the program, the destructors were never called. Okay, so these are statically allocated objects within a dynamically allocated array. So they will be cleaned up automatically, but only if I delete the array. So at the end, I'm going to delete the array using this array deletion syntax. It's not quite up to date, but all right. So then when I delete the array, the dates get deleted for me. Okay. I know this is a lot to remember syntactically. Yeah. Well, your next tutorial will actually help you review all of this stuff. But questions? Okay. So the final one, and the one that we're going to do for assignment 2, is I want to put as much of this stuff on the heap as possible. So I'm going to allocate an array on the heap, but now it's going to be an array of date pointers. Now, previously, I had a single pointer pointing to this array of date objects. Now I'm pointing to an array of date pointers. So in order, the thing that I need to point to a date pointer is a date double pointer. Right, so this is going to be a double pointer that points to a dynamically allocated array on the heap of date pointers. And then I'm going to dynamically allocate some dates and assign them, have my array point to them. So now the memory model for this last one is going to look like this. And this is more or less what we're going to do for assignment 2 as well. This is sort of the most, we put as much memory on the heap as we can, and we keep it off the stack as much as possible. This is sort of the safest way to handle your memory. So yeah. Dynamically allocated array of pointers. What? Okay, so as mentioned, when I declare this, since it's a pointer that's pointing to an array on the heap, but the array is an array of date pointers, I need a double pointer to point to it. Okay, so this here is the type. I put a new array on the heap, at which point, if I tried to print them out, I would get a seg fault, right? So the syntax is the same as any array of date pointers. I just use subscript, and then that returns a pointer. I use the arrow operator. I can print. The fact that it's on the heap does not matter in terms of how I use it. How I use it does not matter where it occurs in memory. It only matters as to how I declare it and whether or not I have to delete it. Most efficient, it depends on what you mean by efficient, but it's, I guess, the safest way to allocate large data structures, right? I do not want to put very large data structures on the stack. It's usually a bad idea. But most efficient, if I know I'm only storing a few dates and my array is very small, then I would probably put it on the stack, right? Because the stack is much faster. In fact, the string class that you guys use, so in the background, there's an array of characters there, right? And it does a bunch of fancy stuff. But one of the things it does is it statically allocates an array of like size 8, right? Because a lot of strings are very small. And that's the most efficient way to do it, is just to put it on the stack. And then, of course, if you assign it a larger string, it says, well, I can no longer use this local buffer, and then it allocates memory on the heap. So there's a lot of classes that will do both, right? Depending on how much stuff you're storing. Yeah, that's a good question. Well, yeah. All right, let's talk a little bit about that. So what is my date pointer? So you can kind of think of, so I have a variable that is, I use to access my array, and it's a pointer. So what does a pointer point to? An object, right? So a date pointer in this case points to a date object. So you can kind of think of when you want to think of what variable should I use to point to my array? Well, what does your array contain? If it contains dates, then you need a date pointer. By the same token, if my array contains date pointers, well, what points to a date pointer? A double pointer. All right, so I would use the same when I'm trying to think of what sort of variable that I want to use to point to my array. You should think about not in terms of it being an array, but think of it as being a single entity. So what do I need to point to a date? Well, a date pointer. Well, what do I need to point to a date pointer? I need a double pointer, right? So that's maybe a good heuristic if you're trying to think about what sort of variable type I should use to point to my array. Hopefully that makes sense, but questions? Okay. So yeah, I can print them out. If I try and print them out here, obviously, that's going to be a seg fault because although I've made an array of date pointers, I've not made any new dates yet. So down here, again, I can make a new date, put it in this date pointer, and then copy that pointer address into my array. Just, the intermediate step, make a new date object, and that returns a memory address that I'm going to put into my array, at which point I could print them out, and then, well, everything's on the heap, so I have to delete everything, right? So I have 1, 2, 3 calls to new. So in this case, I have 3 calls to delete as well. One of those calls to new was on an array, so one of the calls to delete also on an array. All right, so yeah, I made 2 new dates, one 1999, one 2010, printed them out. When I deleted the dates, those dates got to, when I deleted the array, there's no message because whatever, it's just an array. All right. One last thing, I guess, probably this is pretty obvious, but let's go over it just in case. Let's say I do this. What happens? Well, what happened in the previous case is this. I deleted the dates first, and then I deleted the array. So I went through, I deleted this date, I deleted this date, and then I deleted the array, and everybody was happy. What happens if I delete the array first? Well, technically, the array gets destroyed, that memory gets reclaimed, and now I've lost the addresses of these other two dates sitting in memory, right? So if I delete the array first, I might have problems. Now, what actually happens is that that data is still there, right? It's just no longer mine, right? The heap has reclaimed it. But like the heap doesn't always keep super careful track of exactly where that stuff occurs in memory. So if I do it backwards, sometimes it'll work. Mostly you'll get a seg fault. It may depend which version of the, are you kidding? It may depend on which version of the compiler you're using. Sorry, having technical difficulties. 06, yeah. Okay, so if I delete the array first, in this case, I got a seg fault. That seems to be reliably. I've tried it on all three classes. All three classes, I got a seg fault. In previous years, this has actually just worked, right? Because again, if the heap is sort of being lazy about how it keeps track of memory, well, this data is still there. And you can still kind of follow it. If the heap doesn't recognize that you're accessing memory that you shouldn't, you can get away with this sometimes. But yeah. Questions? All right. So yeah, again, that will be tutorial 4. That will be next week. Let's talk about the midterm. And so some of this stuff is stuff that we just looked at. I just want to make sure I didn't forget anything. Yeah, we're good. If you want to review the syntax, right, for all of these different types, it's here. Okay, let me pull up. Put it in here for some reason. So I have the code, and people asked, can I give you the code? And I'm sort of hesitant to do it. I would rather you write it yourself. I think it's pretty straightforward to write. I'm going to like walk you through everything, but I would rather you didn't memorize it. I would rather you actually sat down and thought it through. In both cases, you should end up with a pretty good mark, whether you memorize it or think it through. But the second one, I think, is better for long-term success. So probably not, but I have not decided whether or not to post this yet. But yeah, so this program is essentially, well, I have a class, it's an episode class. It just contains some information on a podcast episode, and then I have a podcast class that manages these episodes, right? I can add an episode, I can remove it, I can get it, I can print out those episodes. So it's just sort of data management. Very similar to assignment 1, right? Assignment 1, however, we had 3 layers. You had the CU window class that contained some panels, and those panels contained buttons. But now you just have one level here. I have podcasts that contain episodes. So yeah, I've left some of this stuff blank. We're going to go over. So the episode class is essentially done. I'm probably not going to ask you to do anything there. This is just a simple, what we call entity class. It carries information. So mainly you're concerned with the podcast class and how we're going to use it to manage episodes. So the first thing is, well, we want to be able to store the episodes. Well, technically, you should be able to write any of these functions, right? So that includes the constructor, the destructor. You should be able to make a function and get the signature correct. You should be able to write any of these or any of these. And you should be able to figure out what the member variables should be. All right, so let's go over that. Okay, so this is essentially my podcast class from the, that we just looked at. So the first thing, well, let's finish up the member variables, right? So this podcast class, I want to store a statically allocated array of episode objects. Okay, so this is what we did in assignment 1. It is the first example we just did a second ago. I'm going to declare an array of type episode. We'll call it episodes. And we're going to give it a size of max episodes. Right, so this is the type of thing I'm storing, episodes. This is the name of the variable, and this is how big I want that to be. Now, statically allocated, so as soon as I declare this, or as soon as I make a podcast, it's going to allocate that array full of episodes, and each of those episodes is going to get the default constructor called on it. And I have a default constructor, or rather I have a regular constructor with default values here. So that's going to work, right? But technically, these are episodes that are created that I don't care about. I'm going to add episodes like information that I want, and I want to keep track of the number of episodes. So I'm going to use an integer to keep track of how many things are in my array that I care about. All right, questions so far? Okay. All right, so that fulfills this. Well, let's start at the beginning. Constructor. So the job of the constructor is to initialize all member variables of the class. So the first one is the name. So I need, well, I have a naming collision here. So I need to say, this name and then assign it this value. I need to initialize that integer, right? If I don't, it might have like 33,000 or something in it. Is there anything else I need to do in here? Okay, this is it. Some other type of array I may have to do, if it's a dynamically allocated array, I would have to allocate it in the constructor, but for this, we don't have to. This takes care of itself. So yeah. The destructor, well, for our purposes, our destructors are mainly to handle dynamic memory, right? There's other uses like closing up files and stuff like that, but that's not going to be our major concern. Our major concern is cleaning up dynamic memory, which means that we should call delete if we've called new anywhere, but we haven't called new anywhere, right? Assignment 1, all statically allocated memory, so this is empty. That's fine. We didn't even have to make it, but we made it, so, but this will work. We want an add episode function prototype defined in question 7 below. I mean, I guess that maybe I didn't include question 7, but so what that would specify is, well, it's got a return type of Boolean to indicate if it was successful adding this student, or sorry, add student, add episode. I made this from a student example, but I want to add an episode object. Okay. All right, so does this look okay to everyone, or is there a problem? Yeah. Should pass by reference, yeah. If you don't, you lose a mark, right? Or half a mark or whatever the marking scheme is. So yeah, it's an object. We definitely want to pass by reference unless specifically stated that we should pass by value. If it was a primitive, you can pass by value. Okay, now what I want to do is, well, let's take a look. Not sure we probably covered this before, but let's cover it again. So I made an array of episode objects, and I want to add an episode object to it. So let's say that it contains episode 1, it contains episode 2, and then these are, the default constructor was called on them, but they don't contain any information that I care about. So I'm currently storing 2 episodes. That means num_eps equals 2. All right, so now I want to add something to this episodes array. I'm going to add episode 3. All right, so I need to apply the subscript, and where am I going to add it? Well, I'm going to add it to the back of the array in the next available location. And if I look at the indices of this array, we can see that if I take the num_episodes variable, that actually gives me the index of the next available location. Okay, so when I assign a new episode, I'm going to use this counter. And I will assign it the value episode 3. So what happens is, well, episode 3, I pass it in as a parameter by value. I'm going to copy it into my array. Okay, we're going to make a copy here. It can't be helped because of the way we allocated our array. We have to make a copy of these things. But that's fine. And then once I've done that, well, now I'm storing 3 episodes, so I'm going to increment this thing. So that now it's 3. And now you'll notice that num_episodes is 3. And the next time I go to add something, well, it's pointing to the next available empty location. Okay, so that's the memory model of what we're doing. So code-wise, I would do episodes at num_eps equals this episode. Again, I'm going to copy this into my array, but it can't be helped. I'm going to increment this, and then I'm going to return true. One more thing we have to do is we have to check to see if this array is full or not. So if num_eps is greater than or equal to max episodes, just equal is also acceptable. But if that's the case, I'm going to return false. I always like to do this even when logically I should never reach this state, because I can't tell you how many times I've reached a state that I shouldn't be able to reach logically because there's a bug somewhere else in my code. So to be on the safe side, I like to do this. You don't have to do this. You could just say, right, logically, if we write all of our code equal, num_episodes should never be greater than max episodes. So I can just check for equality. I prefer this though. All right, so we have a return value, it returns a Boolean. If our array is full, we return false. Otherwise, we assign these things and return true. So for full marks, you need all of these details. Okay, so we need to check to do bounds checks or whatever, pass by reference, assign it to the next available location, increment this, and proper return value. Yes, we should, oh, you mean outside of this function? I mean, it depends on your application, right? That's a decision you can make. We made the decision that I try to add the episodes. If this returned false, I just say, and then maybe I would print out something to the user saying, oh, sorry, you can't add any more episodes. Maybe try deleting some first or something. Yeah. That's, again, you can totally do that. That's a design decision, right? We decided to do this, or I decided to do this, I guess. Other questions? Okay. Remove episode, I'll leave that for you guys. Let's do an easy one. Print, I'm just going to iterate over all of these. less than num eps, not max episodes. That is a common mistake. Plus plus I or I plus plus, either of those are acceptable, or I equals I plus one, whatever you want to do, as long as logically it works. When this is compiled, it's turned into the same stuff. And then episodes at I returns an object, so the dot operator and print. Now, I'm not big on syntax. If you miss a semicolon, that's fine. But when it comes to this stuff, that dot operator is important, okay? Because it shows that you understand what you're storing in this array. So the dot operator is worth a mark or half a mark or however it shakes out. But yeah, but otherwise, pretty simple. I just loop over everything and print it all. Questions? Okay. Print clips, almost identical. The print all episodes, who's on a roll, is clip. Again, I adapted this from the student and university example. Is clip function returns true. What does is clip do? It actually doesn't matter. Who cares? This returns true or false. And so that's decided in the episode class. Here I said if it's less than half a minute, right? So less than 30 seconds, it's a clip. So I would say if episodes at I.isClip, good grief. Then print it. Yeah, that should work. All right, print episode. You should be able to figure that out, right? Yeah. Print episode, remove episode, I'll leave for you guys. This gives us enough to be able to do our little test here, which is, let's fix a couple of things that I know are wrong from previous classes. I'm going to try and remove John. This is not on a roll. This is a set of clips. Okay, so I'm going to add some episodes that look suspiciously like students. And then let's give one of these a runtime of less than half a minute, so that this one will be considered a clip. And we'll make file, so test. All right. Okay, so really terrible formatting. Let's just fix it ever so slightly. Yeah, that's right. No make file. Okay, so all of the episodes are the three, John, Jane, and Jim. The clips is John. He's the only one with the episode less than half a minute. And then I remove John, and then I print all the episodes, and John's still there. I didn't implement the remove function, so what are you going to do? So yeah, that's the programming part. So questions on that? Now, I think it's pretty easy, but again, we're going to be looking for those little details, right? That kind of show that you understand from a memory perspective what's happening and stuff like that. Let's talk about the multiple choice. Okay, so there's 4 multiple choice questions, right? I just wanted to like give it a few more marks and make it a little bit longer, but also there are some questions that didn't fall directly under programming, such as make files. These are good multiple choice type questions. So understand what a makefile does, right? So if I say G, or not a makefile, but any sort of compile command, right? If I do this, which file is created? So it's this, the -c means I'm going to compile to an object file. So this would result in p1.o. If I did this instead, -o p1.cc, then this would make an executable called p1. And if I have a make file, I have multiple commands that are working together. And so I might ask you what files are created when I run this command. Okay? So understand the ins and outs of your make files and your compiling commands. Memory, let's talk about that. So this could get a little tricky. So let's define a class called calendar. And inside my class called calendar, I have a statically allocated date. All right, so assume the date class exists. And then in my main function, I make a calendar. And so the question is, what objects are made and where would they be stored? Right, so if I run this, well, I've statically allocated a calendar. So that's going to be made and it's going to be on the function call stack. But inside this calendar, there's a statically allocated date. So when I make my calendar, when I allocate the memory for the calendar class, there's actually room for a date object in here. Right? So it's the composition, it's stored inside the calendar class. So which objects are made? A calendar object and a date object. And they're both stored on the stack in this case. Okay, questions? Okay, so what happens if I do this? So now what objects are created when I run this program? Yeah. Calendar object and a date pointer, yeah. But not a date object, right? So no date objects are made. I've only declared a pointer in here. So yeah, good answer. So I might do that, or I might ask you any combination. I might do something like this. This is, really nefarious. What objects are created now? Yeah, none, yeah. So we've declared a calendar pointer, but that's it. I did not make a calendar object. If I had made a calendar object, then the date would have been allocated with it. But this is just stores a memory address, that's it. So yeah, any combination sort of like that, you should be prepared for. I can't remember. I may have, I don't think I did, but maybe I put some new, what if I did calendar cal equals new calendar. Well, if I make a new calendar, then I've made an object. It's on the heap, and then allocated along with it as a date. I don't think I did that, but can't remember. I don't know. It's so hard because you edit it a few times and then you forget what state you left it in for the final form. So I would focus on statically allocated, what it means if I just allocate if I just declare a pointer, but spend a little bit of time on this as well. All right, questions? Yeah. Yeah, exactly. Yeah. The calendar and the date would be stored in the heap. Again, because, the date class is stored inside the calendar. Yeah. What's that? The date itself? Yeah, you could do, so let's say that this was public. So I could say, I could make a date D1, and then I could say cal, okay, well, let's run with this definition. So it's a pointer, so I'm going to use this, access the date, and I can assign it the address of D1. So yeah, you can do weird stuff like that. You won't see that. Uh, Definitely you won't see that on this test. Um, on the final, that's sort of fair game, I think, but not here. Other questions? Okay, what else? So where and when are objects created in memory? Again, new is the heap, right? If there's no new, it's not on the heap. Um, I mean, I guess the exception is, well, there is a new here, right? So I made a new calendar, so this would be on the heap along with the calendar. But if you do not see new, there's no heap. There's only the stack. How to use return parameters. So we did see like an example. It was a double num, but let's say it was get input. So I pass this int parameter by reference, which means that inside this function, I'm going to change the value of this number, and it's a return parameter, right? So know how to use return parameters. I think those are sort of easy, but I might try and fool you, right? And just leave that off and then say, oh, well, what's the output? And yeah, so in this case, I'm returning by value. This is not a return parameter, even if I pretend it is a return parameter, only if I return by reference. How to use namespaces? Again, I feel like that's kind of easy, right? You declare a namespace that's inside. If you want to reference something from that namespace, you either scope it in directly or you say using namespace whatever. I'll leave that up to you. I think those are sort of simple. So yeah, that's, again, what should you focus on? Well, there's 4 questions and I give you 5 hints. You should really focus on this stuff. Yeah, questions? Okay. Get input. Oh yeah, in terms of return type, probably it would have a void, yes. That would make the most sense. Right, if it's a return, I'm using a return parameter instead of a return value, then probably it's a void. Or, it could be a Boolean. In the midterm, we'd be asked to make the functions like the add function. Yes. You would be asked to make the same add function that we made down here. Well, I guess not here, but in our coding example, I would ask you to make, yes. So you would have to understand, it's a little test on pass by reference versus pass by value. It's really all it is. Everything else is pretty simple about that. Other questions? Yeah. The return parameter? Oh. Oh, for the multiple choice. Yeah, yeah. Oh, this guy here? Yeah, sure. What's that? All right, I'll just write the function, right? So, and then show an example of it being used. So let's say I make a void get input, and now I'm going to use this int as a return parameter, call it num. So I would just do something like, take user input, throw it into num, and then check the value, right? Make sure it's in the correct range or whatever. So to call this, I would say maybe in main, I would declare a input variable, and then I would say not get num, but get input. Here, let's make this even more explicit. Let's just make this a very dumb function. All it does is it takes this variable and assigns it the value 10. So here I say, I declare an int n, I say get input, and then I say cout n, and what is the output? So what's the output? right? So this is I'm passing by reference, which means that I'm actually passing in some sense, I'm actually passing in this integer, right? So when I assign it the value 10, this integer n, which is stored in this main stack frame, actually gets the value 10, and then when I print it out, it prints out 10, right? That's if it's an input parameter. And I could do something like, even if I initialize it to 0, inside get input, it's assigned the value 10. And then I might try and trick you, and I might say, well, this is passed by value. So in this case, this would output 0, right? Copy of this integer n, I've copied in the value 0, but this is a separate variable. And so when I say num equals 10, well, that local variable gets the number 10, but this is still stuck at 0. All right, so that's input parameters. So yeah, watch out for the reference, and watch out for a little tricky pass by value thing. All right, other questions? Output 0, and we don't use it because we don't have to. Right, so if I draw, so in this case, let's, if we draw the function call stack, I start with main. Main has a variable n, it gets the value 0, and then I have get input. If I pass by value, then this is a separate integer that gets the value. I copy the value from n into num, right? So that's passed by value. If I pass by reference, well, then technically this is not a separate integer. Technically, this is like a pointer to here. So then when I assign it the value 10, it actually gives it the value 10. Right? So yeah. All right, other questions? So you guys are the earliest class, and you ask the most questions. You're the most awake, kind of. I don't know. That is actually usually how it goes. The morning class, you get very few students, but the students you get at 8:30 are like, they're morning people. They're very alert. All right. So like 10, 12 minutes to get through this. So this is sort of, probably won't get through all of it, but object-oriented software engineering. I'm going to talk a little bit about sort of the overall, well, how do you make good programs of size? What does it mean to be a good program? Will the tutorial tomorrow be content review for the test? Unofficially, yeah. I mean, just ask questions or ask the TAs to. So officially, there's nothing planned. You can go there and get help the same as always. But of course, if you can ask them questions about the practice midterm. Yeah. So yeah, object-oriented software engineering. So the thing that always bothered me about software engineering, so I love the technical stuff, right? Because you can prove it and you can test it. It's, it's science, but software engineering is like best practices, and it's like, well, I don't know. I guess that's your opinion, right? Like, oh, the dry principle, do not repeat yourself. Like that's, yeah, I get it. What happens is that a lot of people use it and they find it useful and they pass it on, but that's not really science, and that always kind of bugged me. Right? It's folklore. It's stuff that, well, Bob's been working here 10 years and he finds it a very useful principle, so I use it too. But nobody's done any studies to make sure that this is actually correct. And as far as I'm concerned, the best way to do software engineering is still an open problem, right? Like there's still companies competing, and you could be the next person to figure out a good way to implement something, right? A good design or a good methodology or whatever. So all of this I consider to be open problems, not a clean code fan. No, I don't mind these concepts. I don't like when they're somebody says like these are absolutely true, because nobody's done the studies, right? If you did a study, then I would say, okay, you have evidence to support your position. So it's folklore, which means a bunch of people say it's true, and probably there's some truth there somewhere. Whether it's always a good idea to do these principles, yeah, I would say it's very context dependent and an open problem. That being said, I am going to give you some of these things, and I'm going to try and back it up though with a little bit of evidence from like actual companies and or people in the industry, right? So some of these concepts occur again and again. So I'm going to try and, it's still not super scientific, but we're going to try and give a little bit of evidence for these positions. All right, this is far too big, but we're just going to talk about, we're going to talk essentially about low-level design, high-level design. That's more 3004 though. Testing, and then we're going to back it up with some real-world examples. So what is software engineering? Best practices, strategies, design patterns, etc., used to deliver high-quality software. What is high-quality software? So there's a bunch of things that make, software has to work. It has to be modifiable and extendable, right? All software gets updated. It has to work with other software. It has to be reusable, so to speak. It has to be scalable. If you want it to be successful, it has to be scalable, right? If your app only ever services 10 people, then you can do whatever you want. Your design's not going to matter. If you're servicing 1 million people, though, then there's a lot of design problems that come up as you're scaling. So code that works is the most important thing, right? So I can sell code that works that is a bad design, right? Because the guy that buys it doesn't care. The bad design is going to be a nightmare for me when I try and update it or do a bug fix. But if the code is broken but it's got a good design, like the client will not buy it, right? So what you're going to sell is code that works. For your own sake, you're going to consider things like, how can I make updating easier? And how can I make extensions easy to make, etc. And so one of the things that comes down to is make your code modular, right? So I want to, and we'll talk about what that means. So modular design, well, classes should have a single responsibility. This is one part of being modular, which makes them, they're easy to understand, easy to debug, easy to document, easy to write. And then modular design principles, encapsulation, abstraction, and the principle of least privilege. So let's talk about those. Encapsulation means hiding design implementation. And so what advantage does that have? Well, let's say I make a date class, and it's part of a larger program, and this is C, so everything's public. And so I have a day, and somewhere somebody sets my day to 35, right? This is not a valid value. Where did this happen? Well, good luck figuring that out, right? This is just, it's publicly available. Any piece of code could have come along and changed this value. Whereas if I wrap it in a setter, well, now every time somebody changes the value, I can say like the value is being changed to this. Or better yet, I can say like don't set it to 35, like set it to 30 or 31 or some valid value, right? So this idea of like encapsulation and protecting and hiding implementation details, wrapping them with private accessors, helps you to, for one, track down these types of errors, right? So now errors, if my date is 35, I know this is a problem in my date class and not somebody else calling it somewhere else. So yeah, we hide implementation. We give you some public functions that you can use. Everything else is my business. Abstraction, very similar to encapsulation. It uses encapsulation. I think best this is presented with an example, but let's say I open file, right? So, and then maybe I have a variable v that's equal to open file. All right, what happens when I call this? A lot of stuff, right? So technically it's going down to the hardware level, it's going on the address bus, it's going to your, let's call it an SSD, it's looking at what type of file system you have, it's copying that information into RAM, tons of stuff is happening, but I get this nice simple abstraction, open a file. I know conceptually what it's going to do. It's going to give me access to something on disk, some information on disk that I may want to read or write to or from. But that's hidden behind this abstraction. This is an abstraction. There's a bunch of details, but I don't care. because also those details, maybe this file is across the internet. So there could be multiple ways that I can open a file. But as far as I'm concerned, I just open it, it's good to go. So that is abstraction, essentially. Present a nice, simple, general interface. Principle of least privilege, a design heuristic that helps with these things. So basically, I think to myself every time I make an object, does this need to be public? And if it doesn't, I make it private, right? So I give you the least amount of permission that you need in order to do your task. All right, so that's modular code. And the idea behind modular code is we're going to isolate, different parts of your code. And then when errors come along, I can figure out where that error happened. That's one big part of it. There's more to it, but that's the general gist. High-level design, we're not going to do really in this class. Our programs are pretty small. You'll do that in 3004, but some of the things you would consider, what's the high-level architecture, right? So you have like model view controller or client server, and often that's dictated by what type of application you're making, right? So if I'm making a web application, there's going to be a large amount of client server there. Maybe I make something for my phone or make it for the Xbox. Well, then they have a framework set up and I just buy into that. Whatever. I have to work with the framework that they're providing. So sometimes that's decided for you. I've injected some of my personal experience here. Like you learn a new design pattern, you want to use it everywhere. It just complicates things sometimes. But anyway. I'm trying to move fast, so I'm going to skip a lot of that. Workflow. So wherever you work, you're going to have some sort of workflow. It's going to look something like this, right? So we want to make an application. We're going to do a requirements analysis. So what is this thing we're building, and what does it need? So we're going to talk to the client. Use cases are very, very useful, right? So how exactly, what's going to happen when my client uses this program? So they sit down at a computer. They double click the icon, and then what comes up? Like, is it a login screen? Is it a splash screen, right? So maybe I'm loading something. If it's a game, I have to load a bunch of textures and whatnot. So what happens next? So they log in, and then what happens? A menu opens up. So by sort of going through all of these steps, you're really going to clarify what you need to make for your application. Then you're going to build it. Some people are big on design up front. That has never worked for me. I don't know. I've tried. I can't do it. Maybe it's something wrong with me personally. I like to get something working and then build on that. I have made big diagrams of assignments, and then as soon as I start to make them, I'm like, oh, this diagram is garbage. Like, it just does not make any sense whatsoever. After that, there's testing. So anything you build, you're going to make tests. You're going to have unit tests and integration tests and stuff like that. And then repeat all of that in order to refine what you're building. Refactoring is, so when you're building applications, you run into what's called technical debt, which means I'm not worried about good design. I'm worried about solving the problem, right? I need to solve the problem. If I can't get it working, then a good design is useless. So you incur what's called technical debt, where you just make a bunch of bad decisions, but you get it working. And then you want to refactor to get a better design. So we're going to look at that after we learn polymorphism. This is sort of, I've got 1 minute left, we'll come back to this. So we're going to get to this. This is the design that we're going to use, but that also comes back on the next slide. Testing, so there's unit testing, integration testing, and systems testing. These are all sort of levels of the same thing. Testing, I test a single class. I make sure that it works correctly. It's usually pretty simple to do, very black and white. But then maybe I have 2 working classes. I integrate them together and see how they interact and make sure everything still works correctly. And then basically that's integration testing, and then systems testing is as you put it all together. And that's primarily how we don't take testing, because it's just too much. Like, I don't have time to teach you everything. Now, if you're really interested in testing, take 4004. There's a lot of students that take co-op that have said good things about that class, because when you work somewhere, you will write tests, or usually it's the low person on the totem pole that's writing tests. But yeah, for us, we use it for marking primarily, but we'll come back to that. So that's it for today. So I'll see you guys Thursday for the test. Just do the, do the things that we did today, practice those, and you should be fine.